Alright guys, welcome back. We have another question from chapter 5, and in this question we know that the smooth pipe rests against the opening at the point of contact A, B, and C. We need to determine the reaction at these 3 points in order to support the force of 300 Newton at the left end of this pipe, and we can neglect the pipe's thickness in the calculation. So you can understand two things from the last sentence and the first part of the question that is saying that the pipe is smooth. So the smooth part shows that we can neglect all the frictions, and at the end that says we can neglect the thickness of the pipe. We can consider just as a line, then we don't need to consider any dimension that might affect the moments. But if just a particle, we go with each point and we consider as a very thin line. Before we start, please make sure to subscribe to the channel and share this content with your friend that might find these content helpful, and let's get started. So I'm going to start with the free body diagram of the pipe, and let's go with the different forces that we have. So we have the 300 Newton force in here that makes an angle of 30 degrees. So at point C we have a normal force. Let's call it NC. Same at point B, we have another normal force, which we call it this time NB. And same thing for NA. We have another normal force from N. At point A, let's call it NA. And if we want to find that angle, no, this angle is 30 degrees here, which means this one in here is also 30 degrees, considering that that's a right angle. So this will be 30 degrees as well. And if we want to find the normal force on this, so this will be the normal force. So this will be the normal force, or NA. And if we want to find the angle, we know that this angle in here is also 30 degrees. So we know that that normal force is perpendicular to this line, which is the line of the block. And we also know that this angle is, I'm gonna show it like that, this angle is 30 degrees. And if that angle is 30 degrees, this angle is also 30 degrees. And the way we find this is that we know this will be a right angle, and let's call this angle over here alpha. And also we know this is right angle, which has the same angle alpha too. So when the middle angle is the same, that means these two angles are also the same, which is the 30 degrees that we have in the previous part. And now we have all the angles and all the dimensions are already in the question, so we're good to go with our equilibrium equations. Looking at this, we'll see we can go either read fx and fy first. Before that, let's call our x and y here. Let's start with the fx. So if we go with fx, we have the x component of NA, which we know will be NA times, since we know this angle is 30 degrees, it will be NA times cosine of 30 degrees. And we have the 300 Newton force, which has also x component. The x component will be this one, which will be sine of 30 degrees equals 0, and from here we can find the first unknown, which is Na, and we'll get 173 Newton. We can go if we go with the Fy, we'll see that there is also two unknown left, which means we have to move on with one of the moment equation in order to cancel out one of the forces, and we can go either with point B or C. Let's go with the moment about point B. Counterclockwise positive. As always, we're going to use the 2D shortcut that we have for finding the moments. I'm going to put the link in the description below. You guys feel free to check it out. And for this, we only need the moment. For finding the moment, we only need the force and the perpendicular distance. So if we go with NA, we will have the moment of NC first, which is clockwise, so negative NC, and the distance would be what we have in here, which we know is 0.5 meter. So now we have the moment of NC, we have the moment of 300 Newton force, but this time only the Y component make moment, which will be 300 cosine of 30 degrees, and the distance will be 0.5 plus 0.5, which is 1. And we have to break down NA to X and Y component, then we can find the moment of NA. We already found NA, we know it's 173 Newton. And if we look at it, we'll see that both X and Y component of NA, I'm showing it here, is making a clockwise moment, so will be negative. So we have minus NA 173 times. So in order to go in with X component of NA, we have 173 cosine of 30 degrees, and the distance will be what we have in here, which is 0.26. So 0.26 in here, and the last one is the Y component of NA. So we have NA, which was 173 times sine of 30, and the distance will be what we have in here, which is 0.15. 0, and now we can find the normal force at point C, which would be 460 Newton. And now that we have everything, if we go with our Fy, we can find the last unknown, which is NC. So we have NC in the positive direction, NB is negative. We have 300 cosine of 30, and we have NA sine of 30 degrees. And that would be everything for this part. We already know what's NA and NB, and from here NC, and from here we can find NB, which will be 69.2 Newton. And that would be the final answer for this question. Please make sure to subscribe to the channel and let me know in the comment if you have any specific question in your mind, and we can cover it in the next videos. And you guys have a good one. I'll see you in the next one.